He's talking about...
Thank you very much for inviting me. Just no more Greeks. Just Kalispera. I have to talk on the big task whether the new anti-epileptic drugs developed in the last decade are better than the old ones. This is very difficult to say. I'm talking there with, firstly, on the problem of comparison, then the major obstacles comparing these two drugs together. I will talk about a bit studies and then a few practical aspects on this. So you got here, this is a very famous slide. Many people showed in very different ways. And this shows the so-called classic, probably a better word if you take classic than modern. And you see there's a huge development. And if you consider that behind every drug is about 1 billion euros, you can expect that industry is thinking they are doing a good work developing new anti-epileptic drugs and bringing it on the market. However, there is a big problem in comparison. Just consider somebody eats a bar of chocolate and another person eats another bar of chocolate, and you ask these two persons which is better. Or if I take the joke of my good friend Meir, how is your wife compared to what? So the question is, and even if you take in the next step, you get two answers, of course, because there's a different phenotype and a different point of time, so a comparison is not possible. And if you say, okay, there's a bar of chocolate, was the first one better or was it worse than this? And then you probably think you can compare these two. This doesn't work either. So if you go on this simple level, it's very difficult to compare the anti-epileptic drugs because you had to compare it in one person at almost the same point of time in life to get a real answer. So there are a lot of obstacles in epilepsy to compare things together. Firstly, epilepsy is not a disease. It's defined by neurons who are discharging in a paroxysmal depolarization shift, and the reason of this are manifold. As you can see here, there are different reasons, and these are just the lesional ones. There are already diseases behind this, even mitochondrial defects. So there's a huge complexity in phenotype with epilepsy, and we define epilepsy more on the smallest common denominator, which are the epileptic seizures, and it's more or less a chronic state of the brain with many, many reasons. So it's a bunch of diseases. So does this have influence on the response of anti-epileptic drugs? Yes, it does. Here you have a comparison with lesional patients with different kinds of causes of the epilepsy. And if you compare, for example, mesiotemporal sclerosis, a lot of these mesiotemporal sclerosis are pharmacoresistant. If you take another reason of the epilepsy, perinatal damage, this situation between seizure-free and not seizure-free, that means drug-resistant, is a different one. So we can say here, phenotype matters. So the influence and the efficacy of drugs and phenotypes has a big effect. Now, does a new classification help? Is the classification good enough? If we put patients together which are classified, and if we take the classification of the epilepsy, the old ones where the idiopathic symptom are the cryptogenic, and you all know the patients who were incorporated in studies, they were defined by the seizures and not by the reason of the epilepsy in most of the cases. Then we have this first new classification. There's not really a difference, and then we have now a further differentiation. But still, if you just take the structural part of it, you have a huge bunch of diseases. So the phenotype who's incorporated in studies with anti-epileptic drugs is a huge group of patients with obviously different reaction to anti-epileptic drugs, and depends on the number of each group within this study, the outcome will be different, and I will show this. Now, what do we have on data that new anti-epileptic drugs are probably better than old ones? These are very famous data because these were published firstly very highly in the New England Journal from Kwan and Brody. And it shows that in monotherapy, and if we just take this figure, 61% became seizure-free. Now, with ongoing following up these patients, and later on, more patients were incorporated with new anti-epileptic drugs, this figure did not change at all. This is more or less an observation. It's not really a planned study, but you can take the information out of this that incorporating new anti-epileptic drugs, at least in monotherapy, didn't change considerably the efficacy of the anti-epileptic drugs. Now, if you try to do another comparison, take randomized controlled trials, and here are randomized controlled trials with very different drugs, and if you take, for example, the medicine studies, they are thought to be extremely highly ranked, and you look at the seizure-free rate in these patients, there's a huge variability. So from there we could say that new anti-epileptic drugs are probably better or not better than the old anti-epileptic drugs. For example, lamotrigine 150 in this study, 57% seizure-free. In this old study compared phenytoin, valproic acid, phenobarbital, only 41 or 45 studies. If we take the second part of this slide, it becomes obvious how problematic it is, because we are now just looking at one arm in this study, and this is the carbamazepine arm. And if you look at the carbamazepine arm, look how high the variability of the efficacy of the carbamazepine arm is. What does this mean? This means either we have a huge problem in phenotype here, or there's something wrong with the patients or the observations or the counting of the seizures or something. Because this is first therapy here, and in first therapy we would expect that the variability of the carbamazepine response is not so high as shown here, so we can't use this data really for comparison. Now, this is a very nice evaluation, at least of the new anti-epileptic drugs, and if you look close to this, you have the impression that with the ongoing development of drugs, there's an improvement in efficacy of anti-epileptic drugs. The spread is rather huge, but the line is going up. If you take the second part of this population and you take the placebo part, it's going up in the same direction. Now, the question is, of course, what is the difference between the two? So if you look at the odds ratio here, you see the odds ratio is falling down. That means if you interpret this data and if this data are reliable, newer anti-epileptic drugs are not as efficacious as the older ones. These are only from the new generation, but anyhow, this is a falling line. So if we summarize what we have up to now, we must say we have nothing. We have no real information that any of these drugs used in more or less focal epilepsies is more efficacious than the other drug, taking at least the evidence. Now, I would like to put even more water in this wine here with this paper of Cook published in Lancet Neurology last year. The aim of this study was a completely different one. They wanted to predict, or they wanted to prove that you could predict seizures, and this prediction could help the patient at least to sit down or something like this. And what they did here, they implanted electrodes. The electrodes were in the patients for 4 months, and they had an apparatus here, and this apparatus gave information to this handheld device. So here are electrodes, this is the implanted telemetry unit, and this is a personalized device. What happened? If an algorithm detected here that a seizure is coming up, these implanted telemetry units activated this device to show the patient in the next minute probably a seizure will occur. But on the other hand, it activated a voice recorder, and this voice recorder detected whether the activity of the patient gave noise in a way that it could be interpreted as a seizure. So they took it beside the electrical sign they picked up here with the subdural electrodes, but it could have been subclinical seizures, only seizures in the EEG. So with the voice recorder, they ensured that the seizures they picked up are real clinical seizures. Now, the information which came out, if you compare the patient's reported seizures, so the subjective with the objective part of this, it came out a lot of problems for us all. So if the documentation of the patient of its seizures is correct, the blue line should have been taken, but This thing he didn't detect. So one of the big obstacles in interpreting all these results are that we have the big thing, the biomarker we are using, that means the biomarker epileptic seizure is the worst to be documented by the patient. So, first interim summary. It's always, epilepsy means a huge bunch of different diseases. Secondly, treatment effects vary on the basis of the epilepsy cause. I showed you this. The actual classification does probably not help. It's not good enough, not detailed enough to help us further. Drug treatment is seizure treatment is quite clear, and we are just documenting the effect of seizures. Counting seizures is a huge problem in the system, and the placebo effect is a problem, a growing problem too in these studies. And a comparison between old and new drug does not really exist in a head-to-head study, blinded in any way you want to have it. Now, how can we go out of? What is there evidence that there's a difference between the various anti-epileptic drugs? Now, one way out could be the SANAD study and the results of the SANAD studies. It gives a few information. I think it's a very good study because it reflects everyday life using these drugs. Carbamazepine, gabapentin, lamotrigine, topiramate. Oxcarbamazepine is blue because the statistical figures were not so good, were taken into the study. And because it's so difficult to phenotype a patient, the doctor said just to decide this is a carbamazepine patient, so more or less a focal epilepsy with probably secondary generalization, or this is more a valproic acid patient, and a valproic acid patient is the second study, and this patient is more or less a generalized or unclassifiable epilepsy. And then the randomization was done by telephone. It was all open. There was only the randomization thing, but the numbers of the patient was rather huge. Now, what came out? Firstly, the efficacy. Efficacy here shows that gabapentin is not as efficacious as the other drugs, and the other three drugs, topiramate, lamotrigine, carbamazepine, showed no statistical significance. So far, it reflects our clinical impression with these drugs. However, another type of evaluation gives you completely new information. If you look at the Kaplan-Meier curve, that means the patients who stayed on the drug, the spread is different. You see, lamotrigine is leading, and statistically significant, lamotrigine is much more liked by the patient than carbamazepine, topiramate, and gabapentin, which are equivalent here. There's no statistical significance. So there are two informations out of it. Obviously, the efficacy is not the thing what the patient wants in a study like this, and probably even in everyday life. And the side effect profile of a drug is obviously what the patient prefers in this case. And here, lamotrigine is superior. So the result, and in the summary it was said, lamotrigine should be considered the first-line anti-epileptic drugs with partial onset seizures. And Jackie French once asked in a round of about 10 epileptologists, what would you take yourself if you had an epilepsy starting? And 90% of us said we would start with lamotrigine ourselves. Now, secondly, the other one was valproic acid patients, valproic, lamotrigine, topiramate, and here a difference came out. A difference came out in a way that valproic acid was taken by more patients than lamotrigine and topiramate, and if you take the efficacy data, I don't show it for time reasons here, the efficacy was equivalent in valproic acid compared to topiramate, and lamotrigine was less, but here the superiority, because the side effect profile of topiramate, as you all know, is bigger. So if you take the SANAD giving an information says there's a superiority, not in efficacy in most of the drugs tested here. They are equivalent beside gabapentin, who is less efficacious. But if you take the patient's opinion on this, the patient and doctor's opinion combined, it came out that lamotrigine is superior, so one of the new anti-epileptic drugs. And here in this case, one of the old anti-epileptic drugs, that means generalized epilepsies and unclassified epilepsies, valproic acid is the superior drug in this. And there, they said valproic should remain the first line in treatment, generalized onset seizures or unclassified seizures, and the second sentence was, there is a pregnancy problem and you have to take care of this. Now, if you take the information you take out of add-on studies, and this is I got from Philippe Relin, who evaluated these things one day, you see we have the impression that the efficacy goes up in this line from romacimide up here to levetiracetam. However, the spread is so large that there's not really a difference, and the withdrawal rates are comparable to them. So summarizing it up, only in an open study, which was randomized but otherwise completely open, we got some information that at least one of the newer anti-epileptic drugs could be superior to others, and the efficacy of another new anti-epileptic drug, gabapentin, could be lower, but this had no influence. So what could be the advantage now with this development costing several billion euros? The advantage could be better pharmacokinetics. That's what we know. Most of the enzyme inducers, the big enzyme inducers, are below this line. And do we know reduced side effects? Not really. I mean, if you take topiramate, who has a cognitive problem in many cases, even levetiracetam, which is a good, often used drug, has problems with aggression and others. But we don't have any information whether there's really increased efficacy. Now, the pharmacological therapy, which comes or goes with the institution, and these are the recommendations from the institutions, so NICE, SIGN, American Academy, International League, and the German Neurological Society guidelines have now these kind of ideas. They say, since we didn't show any superiority on carbamazepine, we say carbamazepine is still the number one. Valproic acid, of course, it's the number one because it's more efficacious. Just the German guidelines decided that levetiracetam and lamotrigine should be the number one in focal epilepsies, and valproic acid should stay this in. And just recently, NICE included lamotrigine to this. So if you take the official recommendations, this is a very conservative thing if you look throughout the world. I think we in Germany are a bit more modern. Now, the second interim summary, a higher efficacy of new anti-epileptic drugs could not be shown up to now. Second, by any kind of the analysis. So, is there a reason to use modern anti-epileptic drugs? Since up to now there's no study providing a superiority in efficacy in any syndrome outside focal and generalized, efficacy should probably be replaced by effectiveness. That means a more global positive thing for the patient, and I'm spending a few sentences on this. Take a consideration of a patient, or take a patient in your imagination who has 15 seizures per month, so many seizures, every second day seizures. If you take his ictal time, it's 45 minutes per day if you take an ictus for 1 minute. This is not much for a month. Postictal is 225 minutes if you take about 20, 30 minutes or less. And if you take its interictal time, it's the overwhelming time. So the patient, a difficult to treat patient, we are talking now about this group because the easy to treat patient, it almost doesn't matter what kind of drug we use concerning efficacy, but the difficult one who still has seizures, he's spending a lot of time in the interictal phase. Okay. What does this interictal phase mean? Usually 2 or even 3 drugs. And obviously, even if we are all trained to see the side effects of the patient, we don't do it. This is a publication from Gilliam in Neurology many years ago, and it just used a questionnaire to detect the side effect of anti-epileptic drugs. And you see if they have these side effects with the documentation the patient fills out compared to just looking at the patient and asking him, came out much more of the physicians who got this showed an improvement with the second meeting. So, known anti-epileptic adverse event profile, improvement with the next adverse event profile for the patient, and no increase in seizure frequency, and improvement in quality of life scores. So in these kind of patients, obviously, if you systematically look for side effects, you can improve the patient's quality of life without anything risking his seizure frequency. Another aspect in these patients is depression. This shows the quality of life in relation to Beck's depression inventory, and you see, of course, this is the definition of depression, that you feel bad the higher the score is. But if you look at the seizure frequency in these patients, and these were patients with rare seizures and patients with quite often seizures, you don't see really any variability. So from this we can say seizure frequency does not influence so much the patient, but if a drug causes depression, or if you don't treat the depression, or if you don't change an anti-epileptic drugs, which probably improves the depression, you go into patient's quality of life. Now, do we have other objective data? Of course, 50% of the patients are women, and about 50% of them are in childbearing age. And where's the problem there? And these are recent data now from the Brits, and it shows that the malformation risk in carbamazepine is very low, lamotrigine 2 and levetiracetam, very small number, even lower. So there seems to be an advantage of the new anti-epileptic drugs. And we all know that valproic acid is very complicated, but this figure is dose dependent. But consider the healthy population is 2 to 4% major congenital malformation, depending on the literature. So these drugs are probably even improving, but we wouldn't give it to them. But there's a big but. And there's a recent publication in Epilipsia shows an increased SUDEP rate in pregnancy, and this is probably due, and that's what the interpretation of the people was, due to the lamotrigine. Because lamotrigine is such a difficult drug in pregnancy that this could cause more seizures and finally resulting in an increased SUDEP rate. So it's a complicated issue in this thing. Another study on cognitive functions and valproic acid. You heard that valproic acid is superior to other drugs in generalized epilepsies and unclassified, but however, for the women it's a huge problem. And if you look at the figures here again, and it comes out that valproic acid is really the bad guy concerning the cognition of the children. But however, if you go on the low dose level, the difference is no longer there. So it's a question of dosing also, and to use, and you can use valproic acid if the dosing is correct. And you see here the high IQs, and this is the later evaluation just last year published in Lancet Neurology by Meader and other. Valproic acid results in a lower IQ, but this is dose-related. And the intake of 5 milligrams of folate increases the situation of the IQ, which is 108 here to 101 here. So there's a positive influence, statistical significant. And I don't know how one can say about a reduced IQ if we are talking about 108, the average IQ is 100. So again here, you can solve the problem. Why do we say that newer anti-epileptic drugs are better? This can probably due to the pharmacokinetics. There's the interaction problem of the anti-epileptic drug, not with other anti-epileptic drugs, which sometimes makes a complicated life, but also with other factors here. One of the factors, taking the main enzyme inducers, there's a considerable reduction of folic acid and vitamin B12 and vitamin D, which was published in a huge series of patients, over 3,000 patients were included there. Increase in fatty acid, we heard it yesterday, and reduction of folic acid, which was published by Mintz a year before. And I think one of the really interesting studies, the survival rate of children who are having an enzyme inducer in the background and are suffering from leukemia and are treated with drugs against the leukemia is considerably reduced if there's an enzyme inducer in the background. I mean, this makes sense, but consider you have a patient on carbamazepine and she gets a breast cancer and he gets a complete treatment. Nobody is asking what she's taking. Here we have patients also in kidney transplantation where nobody considers that carbamazepine could be a problem for all these drugs they have to take. So one cannot see beforehand, and we all have about a 30% risk for a malignant tumor. So these patients are in a problem if we take an enzyme inducer. This is another aspect within the efficacy side. Now, in the use focal epilepsy, all epileptic drugs beside ethosuximide and rufinamide, felbamate, and brom are effective, and at least the German recommendations, lamotrigine and levetiracetam, possibly oxcarbamazepine, gabapentin in the elderly, zonisamide, topiramate. This is only monotherapy. However, in generalized unclassified epilepsies, you have a spread. Valproic acid is better than lamotrigine and topiramate. There are differences, however. Ethosuximide is clearly superior in childhood absence epilepsy. I showed this later, and levetiracetam in juvenile myoclonic epilepsy, but not really proven. And valproic acid should be used in pregnancy below 800 milligrams. So the third interim summary is now effectiveness could be a good measure for an added value of the new anti-epileptic drugs. Different patient situations have to be taken into account for this. Improved pharmacokinetics are probably really relevant if you take vitamins, if you take fatty acids, or if you take possibly other drugs in later life of patients. Side effects are still an open problem with the new and the old in the effectiveness, and a complicated thing. So the last step I'm going to talk about is there a possibility that phenotyping the patients better gives new and better information on the drugs? And the first thing I want to say, this show is the very famous publication from Tracy Klauser, and this is the very nice study, ethosuximide, valproic acid, and lamotrigine, childhood absence epilepsy. There were a lot of rumors on these two drugs, how they work or not, and people said, ethosuximide is provoking grand mal seizures. I think it was all a problem of phenotyping, and it finally came out the superiority of ethosuximide. There's no statistical difference between valproic acid and ethosuximide. Lamotrigine was not as efficacious as these two. So doing really a very, very good phenotyping, childhood absence epilepsy, very easy to define in a clear phenotype, you get a good answer comparing new and old anticonvulsive drugs. Here is lamotrigine clearly inferior to ethosuximide, which is an old problematic drug. Now, the Lennox-Gastaut syndrome, there are a lot of studies on this, and rufinamide was developed. This I don't want to go in. I just want to cite this Cochrane database survey where Helen Cross was involved, and there's the optimum treatment for Lennox-Gastaut remains uncertain. No study to date has shown any of the drugs. So here we don't have such a clear syndrome. But however, there's still a study showing some, and I don't know whether you saw this recent publication, stable dosages of clobazam for Lennox-Gastaut syndrome are associated with sustained drop seizure and total seizure improvement over 3 years. So against our feeling that clobazam is losing its efficacy after a short time and we don't feel well using it, this is the study. These are 3 publications in a row with clobazam and showing very nice results, even in a very difficult to define syndrome like the Lennox-Gastaut syndrome. You see the data here. There's even a considerable portion of patients seizure-free. These are drop attacks, CNA, and total seizures are here in a very difficult to treat syndrome on the long hand with a drug where nobody else thought before that this works for 3 years in such a good manner. Now, let me give the last summary. The improvement in efficacy, new versus old compared, is not proven. It's at best felt. We all have the feeling that lamotrigine, levetiracetam are probably better drug than the old ones, but the proof is not there. Pharmacokinetics are often improved with the new anti-epileptic drugs and could be an advantage in everyday using. This is a horrible thing. You should exchange it, spend a bit of money on this and buy a new one. More anti-epileptic drugs, and this is the big advantage for us, gives more choices. With the new drugs, we can use a drug and I showed you yesterday that even perampanel gets patients seizure-free after long treatment with others. Effectiveness instead of efficacy should be the new measures if we want to compare new and anti-epileptic drugs and new developments and encourage the industry to go on with this expensive development. However, there are a lot of obstacles. Beware of the unreliability of seizure counts. I think this is one of the biggest problems we have to solve in the next year if we want to see progress in epilepsy. And be aware of the rising placebo rates. And from the studies, I showed two examples that phenotyping, in one case it was an easy phenotyping, clearly typed. On the other hand, it was difficult phenotyping, very unclassified, shows advantages comparing drugs with each other, and this should be the new way testing anticonvulsive drugs. Thank you for your patience.